Hello, my name is Raj Kumar Bhaiya. I'm from University of Melbourne, Australia. I system as Redmond Barry Distinguished Professor. I am also Director of Cloud Computing at Distributed System Laboratory. So today I'm going to discuss about multi-cloud computing, the concept, foundation, and the application of multi-clouds for big data applications. So that is the focus of our discussion today. So let me briefly present outline of this discussion. First, I will introduce you very briefly the computing utilities and their enablement by different computing paradigms. Very briefly, we'll discuss, and we will take a look at what this big data is all about, what are its challenges, and kind of applications this big data presents. So we will discuss those in the context of identifying requirements of big data and how cloud computing can help support those applications. So then we will discuss a bit more about different application models for creating big data applications and how we can deploy under cloud computing environment and what are the challenges. So the cloud computing has been around for last several years, and during that period, many advances in cloud computing has been made. As a result, we see numerous cloud service providers have established the necessary infrastructure to support cloud application. So that is really success of this cloud computing. However, there are challenges such as vendor lock-in. If you build an application for a particular vendor, so it is challenging when you move your application to new vendor, because that may not work due to change in interfaces and so on. To overcome this limitation, the concept of multi-cloud computing come into picture. This is getting very popular these days to support varieties of applications, including big data. So having understood those challenges and the requirements, then we will take a look at Aneka platform. So here we will particularly look in the context of Aneka technology and Aneka's features for multi-cloud computing. Then some examples of deployment of applications in multi-cloud environment using Aneka. We'll also definitely look at two sample application case studies of big data application analytics on cloud using Aneka. So next we will discuss about applications that are composed as workflows. In this case, particularly scientific workflows. So we have developed a workflow deployment engine that allows you to deploy workflow applications in a cloud computing environment. And we will see how that system supports the deployment of applications from different domains, especially from astronomy. So this technology allows you to deploy varieties of applications from different domain, but we will see the deployment case studies on multi-cloud environment here in Australia. So then we will conclude at the end. So this is the plan for our discussion during next an hour or so. Let us begin with the first. This, as I said, cloud computing is making is enabling offering of computing utility, and it has been very successful in supporting numerous applications. And when we see now, so there are various reports from market research firms talking about what are the biggest trends in cloud computing in 2021 or today, for example. So the very first one is multi-cloud approaches. So we'll make it in order to break the barriers of moving application between different cloud service providers. So far, the cloud computing success is that they're able to support many applications. So predominantly they're deployed in a cloud infrastructure provided by a single vendor. But now there is a need for moving this application across for various purposes. For the purpose of scaling application, for the purpose of enhancing reliability, and also perhaps for the purpose of optimally computing by minimizing the cost of computation. So this is where multi-cloud approaches play important role. So this is the even the market is also embracing this area. The second, there is a lot of discussion about AI, artificial intelligence, how this will improve efficiency and speed of cloud computing. So one is, there are many multi-cloud applications that are also AI application, but AI application them AI technology can also be used for managing cloud system better. And the third, this gaming, gaming applications will more and more run on cloud. So just like you have app running or music and movies like through YouTube delivered through the cloud environment. So like that, gaming application also run more and more on clouds. Then of course, with the success of cloud computing, so there are many who have established or already have their enterprise cloud on premise within organization, but they also like to use cloud in the public cloud as well. So thus you can combine this on-premise and multi-cloud to create what is called as hybrid cloud. So that is other area that is gaining popularity. Then of course with this the situation like pandemic that we see today, so this is actually pushing more towards virtual cloud desktops. So as a result, one can work wherever they are, but they can access this capability. So these are the top 5 trends identified by Forbes magazine and just published this article very recently. You can see, so this multi-cloud computing concept that we are discussing today is gaining very important currency, very important prominence in industrial world. So that is about why cloud computing is gaining prominence briefly. But anyway, we will discuss now about big data. The world is becoming data driven. So the decisions that are made in governments, in financial sector, in investment sector, in banking sector, health sector, education sector. So all of this energy sector, all of these sectors are capturing massive amount of data, and this data need to be analyzed in a timely manner to develop insights. So in the past, many advances in computing technologies was driven by big scientific problems in domains such as high energy physics, astronomy, medicine. But now, so these are driven by big population application. So especially clouds, so are driven by big data application. Now, why big data now? Why it is so prominent today? So you can see the data that is captured by organizations every year is doubling every 2 years. So if you are captured, say within your enterprise, say 1 terabyte of data, next year you'll be capturing 2 terabytes, and third year you'll be capturing doubling. It will become third or fourth will become maybe around 4 terabytes. So it's a very rapidly increasing. And here is the graph that talks about the data growth in like 2009, 10 to 2020. You can see exabytes of data is being growing. Like 400,000 exabytes. Huge amount of data is growing every year. So why is that? Because of large volume of data that is captured through different instruments, including Internet of Things and cameras. And of course, enterprises are recording every transaction is happening. So banks are recording so many transactions. So as a result, massive amount of data, high volume of data is created, and this data is being created at massive velocity. So rapid with. Then of course, the data also varieties of data. So these all are with different patterns, characteristics. So this is creating very interesting opportunity to what we can do about this data. So as data is captured, even one can use it for various purposes, including even at immigration sites. So if you see how people are interacting on social networks, in social network, massive amount of data is created. So just by analyzing social network data, so one can decide whether this person is the right person to enter into country. So not just passport just has a static data, whereas the big data that is captured and the latest status of this person, kind of friends he's associated with, kind of interaction is making, what might be psychologically the person is the right person to enter into your country. So immigration can also use. So this is big data in immigration application. but there are many other applications. So this in a data-driven world, you will see the numerous applications. Science and engineering are are driven by the maximum of data that is captured. So these applications from astronomy, from genomics in healthcare, bioinformatics, these are very prominent applications already. Coming to the businesses and industry, commerce in that area, also the big data applications are there. For example, large number of sales that happening through e-commerce, you want to predict the trend. So when you collect the data for a year of time, at what item will be popular. So now, for example, during December Christmas period, so there are unique item that gain popularity. So therefore, as a company, you can stock those items. That way, you can make them available to consumers quickly. And of course, stock market transactions. You want to predict how your shares value will be. So you can use it. So of course, airline traffic also massive amount of data collected. So perhaps these days, many international flights are grounded due to pandemic, COVID-19 pandemic. But however, they will come back, and of course, in the past, so many way, aeroplanes, the traffic data is collected. So next, of course, this Internet of Things. So IoT, Internet of Things, connecting all kinds of the world connectivity, not just people connectivity or software connectivity, but also everything being part of the internet. So that connectivity creates massive amount of data. So this also we find in social networks, social media, such as Facebook, for example, having millions and millions of users, all of them sharing images and then interacting. So they are also producing massive amount of data. So moving towards medical healthcare, so there are many medical applications. For example, MRI, instruments. When you capture MRI, magnetic resonance instrument, like capturing brain activity data, CT scans, patient records, all this data that are captured, you need to analyze the data to identify insights about health condition, mental condition of a person, how they can be treated. So there again, big data. Then coming to education sector, like universities, like in our own university, University of Melbourne, we want to improve our teaching learning experience for our students. So how do we do that? Especially in lockdown and all these transactions that is happening, interactions happening, all are recorded. But unless they are analyzed, those records, it is difficult to find out how they are learning and how to help them. For example, this year we have conducted our teaching. Then many question answers, many interaction are recorded. But can we analyze those records and predict? So what can be improved to so that next time offering the same subject can overcome any limitations, or maybe emphasize on the topic that student found it difficult through this analysis. That is one example of big data. Then coming to the governments, governments are primarily aim at offering right services to their consumers. They also come out with various kinds of policies regularly. So will this policy change? Will it help? Will it help the economy? Will it help popularizing the services? Will it be of importance to their citizens? So such kind of decision making process also requires them to analyze the data. Thereby they can come out with the right decisions. And of course during election period, so many political parties are also using this data analytics, analyzing massive data in terms of deciding what kind of policies might be better to promote, or either campaign going right, or what they can change, what is the mood of people. So based on this analysis they can change their message, so thereby they can get better votes from their citizens. So you can see the big data-driven world is now scaling its wings across, various individuals of society. Okay. So with that understanding of brief introduction, so let us now take a look at how cloud computing will help. When we say cloud computing, we need to look at system model, we need to look at application requirement, we need to look at infrastructure challenges, we need to look at application program models. So that is what I like to discuss now. So just to start with briefly, how cloud looks like. So what we see is one end there are various cloud service providers who have set up necessary compute platforms and application services, and these capabilities are available somewhere in the network. We as a user subscribe to them and use, and we pay for what we consume. So that is pay as you go model. So subscription oriented services and service that we consume can be compute services, application services, data services, different type of services available. Of course, when we subscribe to the service provider, initially we might subscribe to service provider one, but that service provider might be using capabilities from other providers, putting them together, offering as a this is a model that cloud adopts. Already numerous applications that are offered through cloud computing environment, they to a certain extent they follow this model. If you take a look at few of the applications that we see here, there are numerous applications of cloud today, and cloud is really successful in terms of its ability to offer all these applications as services, subscribe services, and users pay for the services based on what they consume and pay as you go basis. So say applications such as customer relations management, and then other applications such as like for example Dropbox offers you a cloud storage service by harnessing storage from multiple vendors. Like that, Twitter, Facebook, many of these applications are running in cloud. Even the Zoom that I'm using to present this talk is also using cloud environment, which is called cloud-based video conferencing software. And often these today they tend to be hosted on a single cloud service provider. But as we move forward, the need for making this application, the vendor lock-in barrier need to be removed. Thereby we can migrate this application to different clouds very easily. And you can see there are numerous companies are already offering cloud services. You name it, there are numerous companies in different countries. Like for example, Microsoft Azure in US, very prominent, of course, worldwide too. Then Amazon is also very prominent. Amazon AWS, Amazon Web Services. Then Google is also came into picture into cloud services. You can rent compute capability from Google. So this is infrastructure cloud services. Likewise, even other companies which are offering managed cloud services such as IBM and Fujitsu. In other countries like China, Alibaba is also one of the major prominent cloud service provider. And we can also set up your own enterprise cloud in your own office by using software systems such as VMware software or OpenStack software. Then of course our own technology Aneka is also another technology available to set up a private cloud. Like this, there are many cloud service have come into picture. This is actually a good thing, that is success of cloud computing. However, it creates a new challenge. So if you, for example, you created an application for say Microsoft Azure, and you want sometime you may want to move that application from Azure to Amazon or to some other cloud provision provider. So this can be a challenge. So because when you build an application that is tied to a specific infrastructure characteristic, it is difficult to move. And then other reason you want to move is not only cost or just migration ability, but also scaling. So you may want to scale your application across multiple crowds because no single provider can have a presence all over the world. Say for example, say Azure, Microsoft Azure may be more dominant in USA, then Alibaba may be more dominant in China, and likewise there may be other local cloud services providers in Australia. They are more prominent in Australia. So like this, different countries have got different local homemade or local companies offering this. So for various reasons, you may want to scale across to enhance reliability, to enhance scalability, or sometime to conform to government compliance. So for this purpose, you want to move around. But of course, offering these cloud services to users all over the world, from single provider, as I said, can have a challenge such as scalability, reliability, and also maybe not able to provide the best quality of services that end users are looking. So these we need to overcome these limitations. So how can we overcome? We can overcome by moving towards multi-cloud computing model. So thus we can deliver and also offering these multi-cloud computing services in a seamless manner. This is also very important. If application developer or users have to change the way they use, and that of course obviously creates a lot of pressure, lot of effort is necessary to migrate application, maybe recode the application or change the application code. That's all too much. So we need to minimize cost of software engineering. So this is where we need to look into different solutions. So when you move to cloud, what are the benefits? As I said earlier, the first benefit is you will have access to multiple cloud service providers who are offering services at different prices. That means you can have a competitive access to competitive prices. If you are just stuck to a single service provider, so they might be increasing their prices regularly. Yeah, you don't have much choice if you don't have multi-cloud facility. You are just stuck with there. So here you can take advantage of competitive prices offered by different providers, and thereby you can move your applications dynamically to minimize your cost of computation, minimize your bill. That is the first advantage. The second is fault tolerant. If in a big such a large environment, cloud services supporting thousands of users, anything can fail at any moment. We need to tolerate those failures. So there is something multi-cloud help provide you. Then thus we are able to provide highly available services. So imagine you are running your application, say banking application on a cloud. When we say banking application, is not only standard customer transaction, but also banks are providing, credit card transaction support and so on. So these days, in like we don't carry cash. We are more basically, plastic card. The world, you have a credit card and use credit card to pay for your services and goods that you purchase on the move or wherever you are. If this banking system fails or service unavailable because the cloud is got disconnected or there was some problem, this is a big issue. It impacts on our livelihood. So therefore we need to make sure that highly available cloud services are are made available in the marketplace, and that is can be made possible through multi-cloud. Then finally, the major benefit of multi-cloud computing is that you don't depend on a single provider. You have way to move your application, migrate to other providers as necessary. So for either competitive price reason or also for the purpose of offering best quality of service. Say, for example, if you set up a cloud application service and very popular in Australia and also US, and later on you want to offer them in China, in India. So in this case, you must be able to seamlessly migrate your application capabilities to all these locations and harnessing different vendors over there. So you can offer best service to the users worldwide. So these are some of the key benefits of multi-cloud computing. And of course, which also means that we need to build necessary application creation and deployment platform to support it. Then of course, in when you come to big data, sometimes the massive amount of data that is captured, but you want to make decisions in a timely manner. So you don't want to wait for a long time. So for example, if you do it on your enterprise cloud, maybe some of the investment risk analysis task may take 2 hours, but you want to make real-time decision. Maybe you want to make decision within a minute. So that requires you to use multi-cloud, but that also requires to have necessary the software platform, application platform that allows you to do it. So before that, in terms of composing these big data application, so we need different application programming models. you know and this big data application can be coming from different domains like scientific computing, business computing, and so on. And when we look at this scientific computing, they have their own requirement. The business computing application, they have own requirement. So therefore we need the environment that is highly scalable, both in terms of compute, network, and storage, and it offers privacy support, and also offer services within certain cost limit, budget limit, and also accuracy. You should also be able to trade off accuracy versus timeliness. Say, for example, if you're looking for a pathway from A to B, and then your analysis task takes 5 minutes, but I want answer in 1 minute, but I can compromise a little bit of accuracy. If it is 80% good enough, that is fine. So this requires you to trade off between cost, time, and the level of accuracy. Such are the unique need requirements of this application. And of course, when we want to construct or create this application, there are different programming models available for that purpose. So to start with the very simpler one, in cloud environment, you want to harness the power of multiple cores and multiple servers that you provisioned, and which means your application has to be designed to harness it. So here are some of the models that you can use to create such application. For example, thread model programming. So generally, the thread programming is mostly associated with concurrent computing on shared memory systems. Shared memory, for example, a server with multiple cores, where thread model programming is traditionally that is used. But can we extend the same model towards cloud? That is very important, where we can run threads across multiple servers, not just within one server. Next, this task model called SPMD, single program multiple data model. This is also very prominent in constructing application. So we need to have that support. Third, MapReduce is another dominant application programming model, wherein you can easily express concurrent tasks in the form of map. They process on a multiple servers. After that, you collect the results from multiple servers. That is called reduce operation, then present aggregated result. So this is another model very prominently used by numerous companies. Then there are some applications which are message passing oriented. So if you have an application composing of multiple tasks, and these tasks are not independent, they want to talk to each other by passing messages. So how do we do that? Then of course, some tasks are parameter design sweeps, like design exploration. So you have certain application, you have got numerous design scenarios, numerous parameter, like especially in case of what if analysis, like when investment risk analysis. You might say, what if I invest this much money across these many portfolios, and I'm willing to wait for 5 year or 2 year or 1 year or 10 months. So if you have got various scenarios analysis, so we need to be able to support such parameter sweeps. Then coming to workflows, usually in real world environment, you connect various operations, and that connected task is called workflows. So obviously, in case of workflow, for example, here I see a diagram of workflow. So we have various stages. One A, task A. Once it completes, goes to B, and then from B, you have other few more tasks. They're running in parallel. They may be sharing data sets and processing. Then finally it ends. And how do we support composition of such application? So these are different models of programming, and we need to have, once we build the application using this model, so can we ensure that application can execute across multiple vendors, clouds? So that way we can make sure that it is highly portable. So that is conceptual discussion and the requirements of multi-cloud computing. So now let us take a look at some of the technologies that are out there, including our own Aneka and Cloudbus that we developed, that support multi-cloud computing for varieties of applications, including big data. First, let us start with this Aneka. Aneka is essentially application platform as a service. This is built on .NET. And as a result, you can program, you can use Aneka, programming capabilities from more than 10 programming languages that are supported by .NET. So automatic support. Then Aneka supports multiple models of programming you can use along with APIs and tools to build your application. Let's take a look at in depth. So this Aneka, to briefly, is a cloud application platform for building resource-intensive, compute data-intensive application and exhibit elastic property. So in that regard, Aneka has a first component called SDK, Software Development Kit, that has all these varieties of APIs and tools that one can use to build applications rapidly. And once you build that application, you can deploy on enterprise cloud or public cloud or multi-cloud in a seamless manner. So that second feature is made possible by our runtime machinery. So we'll discuss more of these as we go along. And these two are the unique elements of this Aneka. which is what it makes it world first platform supporting multiple models programming. And once you build those applications, then you can deploy it across multiple clouds, not simply deployment, but also deploy based on cost optimization, based on quality of service requirements of users. We will see some of those. This is what it makes it very, very unique. So when we take a look at this Aneka cloud application platform, so let us say we deploy on different infrastructure. So once you deploy, what you get as part of the deployment of the Aneka solution is that, as I said, SDK containing different models of programming like thread, task, MapReduce, using which you can build varieties of applications from image processing, gaming, life sciences, healthcare, COVID data analytics, so gaming, smart cities, various of application you can compose using these models of programming. And once you compose, you can deploy. And when you deploy applications in a cloud environment, you also need to be able to manage users, manage your application, manage quality of services. Then, of course, if you're using enterprise cloud, every now and then you may have to harness power up public cloud. That means you must be able to dynamically provision extra resource from public cloud to meet your critical needs, at the same time minimize cost of computation. So here you see Aneka is more as a software platform that you can deploy on different infrastructure to support different applications. So with that understanding, let's take a look at how Aneka works in terms of application execution very briefly. Here is a simple, image, and I like to analyze this image to, for example, process this image and apply certain filters to convert this image into, say, for example, emboss. So in Aneka, using thread model programming, you can take this image and you can split that image into multiple rows, multiple columns. So for example, it makes 9 image segments, and each of these image segment become Aneka thread. And Aneka provisions resource in private or public cloud, then take this task and do the processing on cloud environment. After processing, the results come back to the application. So when the results come back to the host that is submitted, that goes to the application. In this case, application, for example, we applied emboss filter, that image is turned into emboss filter. And meanwhile, whatever resources that are provisioned in cloud environment are clear. Why? If you just hold on to it, they keep charging you, because cloud is a metered service. They are measuring how much you're using, accordingly they charge you. So in the first generation clouds tend to meter based on hourly basis. Whether you use it for 1 minute or 1 hour, they charge you the same price. That is how the previously. But the latest clouds have changed that policy. Some of them are charging based on minutes, some of them even charging based on seconds or few says. So because the meter service, we need to use them wisely. So Aneka does this dynamic provisioning, not only provisioning within one cloud, but also across multiple clouds. So my aim of demonstrating this, and with through animation, is to demonstrate how Aneka works. And moving towards multi-cloud, as I said, there are multiple cloud providers such as Azure, Microsoft Azure, Amazon, OpenStack-based clouds, private clouds, then Google. They're like this. Multiple providers have come into picture. So we want to support deployment of this application that you create using Aneka across these multiple clouds in a seamless manner. Okay, obviously the way Aneka works is that, let's say in one of the place you have a cloud and Aneka is running. Then in multiple places you can have Aneka workers that can be dynamically provisioned, and you can make Aneka workers that are provisioned in different clouds. Connect with the home resource, then run application in a seamless manner. So for example, here you see a private cloud, public cloud provider 1, cloud provider B, like this, say 4 clouds, and you can use them in a seamless manner. That's what Aneka does. Then you can see if there are multiple cloud providers, each of them may use different technology to create that cloud. So and how does Aneka make this possible? So Aneka makes this possible across multiple cloud in seamless manner to ensure portability of portable execution through different adapters. Aneka has various plugins. Using the plugins, you can easily, seamlessly run your application across multiple clouds. So you don't have to modify your application code. So instead, Aneka allows you to do that in a seamless manner through our adapters. So to give you some analogy, say for example, you have a laptop and you go to different countries. So let us say you are in your country. For example, I am in Australia. So yeah, my laptop, to connect to a wall socket. So our socket, these pins look like this. And let us say later I visit India or China. So there, if I try to push this, my power cable to the wall socket over there, it will not go because there it looks different. So therefore, I need to get another adapter for China, adapter for India, adapter for USA, adapter for Australia, like this multiple adapters. You can see. So similarly, in software area, each of these cloud service providers, they have their own technology. Microsoft Azure, it has its own approach. Amazon has its own approach. Google has its own approach. Like this, different products have the different approach. So therefore, what we have done is we have created adapters for each of those and then a link to Aneka. As a result, Aneka becomes a common application platform, and now Aneka knows its how the remote cloud resources infrastructures work, how to access them, how to manage execution, how to control it. So using that seamlessly, application can benefit. So that is how we have done. We have created Aneka adapters for OpenStack, for Gen server, Citrix, for VMware system software, and also for Amazon and Azure. So this way you can run your application across multiple cloud in a seamless manner. So that is our multi-cloud computing and Aneka is not possible. So this Aneka, has been used to compose and deploy multiple applications in cloud environments. So here are some few example applications from different companies, from China Southern Railways, from Indian Space Organization, from Washington State University for medical data analytics on a cloud. Then also recently at Melbourne University, we have done on this COVID research data analytics in a cloud environment. So there are many of these applications, but today I want to focus on multi-cloud. Okay, so I will give you more and more example of how Aneka has been used for multiple computing. So here is one from, for example, Indian Space Research Organization. So this ISRO, Indian Space Research Organization, regularly runs different satellites. So there were, like for example, Moon mission, Mars mission, various missions are there. They launch satellites. Sometimes they launch satellites for disaster management. So here is one satellite that is launched recently. So that monitors Earth data, and data is collected, and data comes back to receiving station at the local. And then of course the data that is captured, that is stored in, let us say, multiple storage clouds. And you want to analyze this data to find out, let's say, where is this disaster occurring and what time it is occurring. And to manage the disaster, you need to do this disaster detection in timely manner. If you do it on one cloud, it might take, for example, say 5 hours. And this ISRO has built this medical this space satellite data analytics for disaster management. They use our Aneka software to compose this application. So if it is taking few hours, like 4 or 5 hours, but in case of disaster management, the decision has to be made in a timely manner, maybe within 10 minutes to plan for disaster management. So this is not possible to do it in one cloud. So in this case, one can use Aneka to run across multiple cloud environment. So for example, such organization having their branches in different places, they can use clouds from different data center from multiple location to do in a timely manner. Or in some critical situation, they can rent extra cloud resource from Amazon or Azure or Alibaba, whichever is available at the lowest possible price for your application, and deliver answers in a timely manner. And you can see, so this is a seamless benefit of multi-cloud computing for such application. That's one. The second, the big data. So big data, as I said, there are numerous applications. So this COVID-19, from the perspective of capturing patient data, is creating a lot of data. And also, even the researchers around the world are doing a lot of research on finding out, what is the best vaccine, or what is the protein structure, what is effective in terms of social distancing, what are the risk factors. So there are already more than 130,000 papers are published during already 5 to 8 months in the field, but you want to find out which are the best ones. So if you try to analyze each one of those, go through manually, it can take a lot of time. So we need to automate this process of mining this COVID-19 research data. Okay, for that purpose, we have set up we created an Aneka based application that does machine learning, having multiple Aneka tasks. It is able to run across multiple servers within a data center, then deliver answer in a timely manner. So this is a application workflow from right from data connection to storing the data, then Aneka doing the processing using various machine learning algorithm. Then after that, presenting the results. So this is an example. So a research paper on this is published recently, and soon I will give you pointer to the paper. Then here are our brief results on, running this machine learning for this COVID data analytics on multiple nodes, multiple cores within cloud environment. So, for example, if you provision a single server, so it might take something like 900 seconds. So, which would be some 900 divided by 60, maybe 10 minutes. The same thing, you might do it in a minute just by using multiple servers in a cloud environment. So this result shows you how you can minimize the time to discovery. So, and of course, you can classify all these papers based on various factors, including classify into countries and also into organization, and within organization, what kind of paper they are publishing. So this is here is a view of how it happens. For example, number of papers, for example, published in by University of Melbourne. So when we did analysis, it was showing almost 129 papers. But obviously, but if you do it today, perhaps it will be 150 or 160. So more are published with University of Melbourne affiliation. Likewise, you can see globally. Okay, so that is high performance mining. Now let us take a look at deployment studies of this Aneka technology for few of the application where we are able to harness two different cloud environment, two different public cloud environment from commercial environment settings from Azure from Microsoft and AWS from Amazon. So for this purpose, we take a look at so having understood Aneka technology. So let us take a look at how we can deploy, and application that I've chosen here is one application called Blast, which is a basic local alignment search tool. So this Blast is from National Institute of Health in the United States. So it's available freely. So this software allows you to search, sequences of nucleotide or proteins in one or more databases. So these protein databases are also distributed, and you want to analyze them using this tool to find out necessary answer. So what we did was we downloaded this database from NIH, which NIH National Institute of Health. They have a American Center for Biotechnology Information, so which is called NBCI. So here we downloaded the database. There is one database called E. coli, and the size of this is something like 4,600 KB, and each task when it executes one query, so we are able to perform such multiple queries for the same database, and of course each query may have short data, but you do across multiple. You can issue multiple queries. For this experiment purpose, we just to simplify and demonstrate this concept, we created an Aneka-based cloud having resources from Amazon EC2 and also from Azure. So in this case, so Amazon EC2 virtual machines were located in Asia Pacific Data Center. So here in Australia, Sydney. Sydney is one of the prominent city. whereas I am based in Melbourne, but Sydney is another city, which is also a big city. So where so this has, Amazon is data center is there, and there we are able to create a virtual VM running Windows OS. Then other one we use Microsoft Azure virtual machine located in Southeast East Asia data center, so which is actually Singapore. Of course, nowadays more and more, more than I think close to 20 or more regions around the world where Microsoft has established cloud data centers to offer Azure services. So you can see you should be able to use multi-data center and multi-cloud data centers from different vendors. So how does this multi-cloud resource provisioning works? So here I'm giving you just a very simplified approach to multi-cloud resource provisioning. Say, for example, you create a multi-cloud resources with, for example, pool of virtual machine instances. So then, of course, obviously in multi-cloud environment, if some resource is available freely, suppose you are combining private cloud and public cloud. So your private cloud maybe is available freely, or you want to encourage its use, so you can allocate it. Otherwise, you want to use remote cloud, public cloud. Of course, while doing public cloud, you want to make sure that you have enough budget. The cost that user is constraint, budget constraint is put there. There must be enough budget to create on-demand instance. Suppose if there is no budget, obviously you have to use the local one. But if there is a budget available, so yeah, and then which one is the most suitable for your requirement? Multiple cloud providers are there at different price. You need to choose one that meets your requirement, which also offer reliable services. So that is very simple approach to multi-cloud computing. So we looked at executing this blast linear sequence analytics application execution for various protein sections. So with looking into number of tasks, one we did with 80 tasks. Another execution we did it double, that is 160 tasks. So here we are able to run these tasks by provisioning different number of virtual machines which runs Aneka worker. So for example, in case of 80 task blast 80 task execution, so we just looked at how much time it takes if I just provision one virtual machine from Azure. In our scenario, it just took around 16 minutes, about 16 minutes to execute this task. So next, then we said, what about if I provision one more machine in what happens? So obviously the time it reduced by half almost. Then like this, we added third one, then it reduced furthermore. So this the first type of experiment was primarily done using only virtual machine from Azure. Now let us say you just found that you have another resource in Amazon. Maybe Amazon is giving you one virtual machine freely to you and use it. So you have three from Azure. Then we provision one more from Amazon. So as a result, we have end up having four compute elements or virtual machines or workers that for you. And when we run with four, so initially what took around 5 minutes 28 seconds. So the same thing we're able to do it in 4 minutes 30 seconds. So you reduce the time to compute. So now, of course, obviously, maybe you saturated with the number of VM that you are able to create on Azure 3, but now you can provision extra. So provision second, so one more resource like this. Then you have two from Azure, Amazon, another one, three. So like this, when you run, the total number of compute instances that you provision can dynamically change from 5 to 6, and you can see the time is reducing from so for four workers 4 minutes 30 minutes, then three worker 3 minutes 12, then for one worker 1 minute 50 seconds. So this is how you're able to reduce the time to compute. So that means whenever you got a deadline, different deadline. So if you want answer in say 4 minutes, the Aneka can provision right amount of resource for you. So Aneka has deadline aware scheduling algorithms that takes care of it. But I want to illustrate this concept how Aneka works high level. So now, for example, instead of 80 tasks, we also looked at what if I got 160 scenarios that I want to analyze, 160 tasks. A similar study is made in this case, for example, in 160. This in case of this blast application. So 160 tasks execution on a single node, single virtual machine took close to 35 minutes. Then, of course, if I increase more, if I provision extra resource, instead upon one more 2 3 4 like this, then the time to make decision is also reducing. You can see on the right, 34 minute and then 20 minute and 13 minute like this. As we provision more and more resource, then the time it takes is also reduced. Say for example, here you see, so 3 from Azure, 3 from Amazon, it took us 3 minutes 36 seconds. So now you might say, hey, I want answer in 1 minute. So here you can manually provision. So, but this is too much complexity. Other is Aneka has a done. You might say, hey, my deadline is equal to 1 minute. And then I need to use these resources. Obviously, in a cloud environment, for example, if you look at Amazon itself, they provide very many types of virtual machines. So some of them are called standard virtual machines. Generally, they are expensive because when they create a virtual machine that is just dedicated for you, and the price is fixed when you rent it. So there is another type of VMs called spot instances. So these spot instances, for example, standard virtual machine cost you, say, let us say 10 cents per hour. The spot instances, sometimes they are offered even at 1 cents per hour. So because this is a spot market where you are able to bid, you might say, hey, so right now it is 1 cent, but if the market demand increase, it may become 20 cent or 5 cent. So therefore, they ask you to what is your reserve price. You say, okay, all right now you're charging me 1 cent, no problem. My reserve price is 5 cents. So now, in case, so your application is running on that spot instance, just paying 1 cent per hour. But with time, market demand can increase. So this Amazon may increase the spot instance price to 4 cents. Oh, you are still within that limit of that 5 cents, so you can still run. But if market price increased from 4 to say 6 cents, but your reserve price is 5, so what happens in the middle of the execution, Amazon may terminate your instance. So that means this is a bit unreliable. So, however, there are cases when you are doing large scale design analysis, you can take advantage of spot instances to minimize your computation cost. For some reason, okay, the market price of spot instances increased. It is more than your reserve price. Some of the instances may be terminated. No problem. In large scale computation, you can just switch out to other. So this is where multi-cloud computing, where dynamically provisioning, you can provision standard instances and then do reliable computation. So you can see the cost minimization is something made possible through these spot instances. So you can, based on your workload, based on your situation, you can Aneka helps you to choose right set of virtual machine to minimize this cost of computation of your application. So this is how Aneka supports. So I will give you pointers to few of the research papers where you can read more about this deadline-based scheduling, cost minimization, and so on. Okay, so this is conceptual understanding of how multi-cloud computing works and how it can be made possible. And this is illustrated through Aneka. So that is about Aneka platform. We support thread, task, and MapReduce. Now let us move on to another technology that we developed called Cloudbus workflow management system. So this workflow management system is particularly designed for scientific application. In case of scientific application, large massive data sets, usually legacy applications, and you want to execute them and compose them as a workflow, and then do necessary engineering. So let me briefly share how the architecture of how we architected this Cloudbus workflow. The right side, our workflow engine comprises of workflow portal. That means you can compose your application graphically. You can create connected task and define what code to run when something finishes and move on. That is a graphical environment. Then once you compose your application either through graphical environment or using your XML language, and you want to run that application on multiple clouds, for that purpose we have got workflow engine, so which we call Cloudbus workflow engine. So this engine has various components, including task execution manager, dispatcher, scheduler, resource allocator, fault tolerance, and then negotiation services. Accordingly, they are deployed across multiple clouds. So various components of this Aneka makes this happen. So using this workflow engine, there are numerous applications are created and then deployed in public cloud environment and demonstrated their usefulness. One such we did along with our collaborators in Singapore, called A-Star Institute. So where they are able to do spatial and temporal data analytics for predicting outbreak of dengue fever. A few years ago this was a big issue. Of course, now outbreak is this coronavirus pandemic. So this became global, very serious issue. Anyway, outbreaks are happening all the time. How are they, spreading? The spreading and predicting. So if you have certain policy and you want to curtail and control, so maybe such an application will help. So this A-Star has Singapore have used our workflow engine and compose this application. In this case, there is a data set, climate data set, then geolocation data set, and dengue records data set. Then various analytic models are created as systems. Then they're able to compose that application workflow. And then using our workflow engine, able to run on Singapore cloud and multi-cloud, public cloud in a seamless manner. Aneka is able to take care of resource discovery, resource selection, resource negotiation, then scheduling the task on the right resources, and manage execution and monitor how things are going. If something fails, move it to other place, and then of course bring back results. After results come in, then visualize the results in a again graphical environment. So this is stitching the whole process together. So this multi-cloud concept, we already discussed how it works policy. Now we want to run this application. So another one I want to give you example of astronomy. So this is something we ourselves have done at Melbourne University, looked from the perspective of performance and also reliability. Uh, um, so you can see our workflow engine, little more details. Our workflow management system runs on uses our resource broker. Then for multi-cloud computing, we also use another plugin to which is called Apache J Cloud APIs. So that already provides you abstracted way to access multiple clouds. So then of course this workflow engine also uses tuple spaces to manage events. So we looked at this scientific application, astronomy application. This is an experiment. This mosaic is the application that is used, and this mosaic, the for processing image mosaic of software. This is software used by astronomers. So this is a toolkit. It is very flexible. So in astronomy, you capture lots of images like a sky survey images, and you want to able to generate mosaics from this data set created by numerous telescopes. Say you can see here there are many telescopes such as Hubble Space Telescope, then Digital Sky Survey and Solan Digital Sky Survey, and there are various telescopes in Australia. I'm sure there are many in India, China, and other countries as well. And all these telescopes capture the data, and the data you can access from this site. And this application is called Montage, which is used for creating mosaic. And this application is available from Caltech. California Institute of Technology. So we got that software, and using the software you can create mosaic. And so this application is actually quite IO intensive, data intensive. So for simple demonstration, we looked at analyzing the mosaics with 110 tasks, 110 tasks, and where number of tasks indicate number of images analyzed. Suppose if you got 10,000 images, you have 10,000 tasks. So in this case, just for analysis, we just did it using 110 tasks to demonstrate this concept. And here is the composition of this workflow. So where, for example, the default workflow generator used to create, for another workflow engine called Pegasus. So we are able to convert it into the format that is acceptable to our workflow engine. And when we compose that application as workflow, so it looks like this. You can see there are various tasks at the top level. When the task is finishes, you move to the next level of task. Then when that finishes, then you can move to this red one. You can't directly go to the red one because the output of this first task become input to the next, and the output of that becomes input to the next task. Like this, it follows. Then sometime it spreads, sometime it merges. Then finally it becomes sometime pipeline. Then you finally have a result. So you can see here when you are at this stage, you have an opportunity to spread this task across multiple clouds. So when you spread, you can spread it for the purpose of performance, and also from the perspective performance of reliability. Suppose if some task fail or some resource fails, how do we do it? So we looked at both kinds of experiment. Okay, I hope this workflow, you are able to get this picture. And the similar thing you can also find in the business domain. When you look at any business process management, in business process management, there are the interconnected tasks and the flow need to be happening. Even for example, approval process. Say for example, there are multi-stage approval. So you have certain documents, certain things approved by a person, manager level 1. Then from there it goes to next level. So they manage the workflow. It goes to next level. Like this, finally it gets approved at the more aggregate level. So that is the business process. But in scientific domain like this, in medical or in astronomy, these connected tasks are there, and they need to be analyzed as per the workflow, which is very, very important. So here, so we looked from the perspective of reliability. Say here we have one cloud at Melbourne University. This is our cloud. Then there is another cloud, obviously this Amazon cloud based in Sydney, which we also discussed earlier in our previous experiment. So given so these two clouds, and we want to run this mosaic creation of 110 tasks, and we want to set a deadline. I would say I want to get this answer within 55 minutes. So given a deadline, so this workflow engine is able to provision. First, it is using essentially all the local resources. Um, then of course you can assume, or even public cloud, you can assume that there are no failures. So everything working perfectly. In which case it is, you can see here when we compute and use multiple cloud resources. So here we use our Melbourne cloud, 4 virtual machine. From Amazon, we use micro virtual machines, 3 of them. So with this experiment, when we run with no failures of any task, everything went smoothly. So it just took 39 minutes, 45 seconds to give us the answer. Because the deadline was 55 minutes, so there was no need of provisioning too many resources. Suppose if you had said deadline as a 20 minutes instead of 55 minutes, and obviously it would have provisioned much more resource from the public cloud. Okay, so in a second scenario, all right, things are happening fine. During execution, one of the resource fails. Failures are common. It can fail for any, there are numerous reasons why this resource can fail. So when they fail, so in that case, it actually took more time to execute. because we need to quickly identify which resource failed, then where it failed, and then migrate that task from the failed resource to another one. So as a result, it took a bit more time. So like this, if number of failures are increasing, obviously it takes more time. You actually sometime even cross the deadline also. But the Aneka system is able to tolerate those failures, still operate and do the task and within this 55 minutes. So if there are more failures or maybe your deadline is very tight, at that time, no problem. Hey, so let me provision extra resource and quickly and not exceed the deadline. So do within the deadline. So this is how Aneka is able to support for reliable execution. So therefore, multi-cloud can be used for not only enhancing performance, minimizing the cost, but also enhancing reliability of services. So applications from banking, health banking sector needs such services. Of course, these days every application need to be available to us anytime we want. So reliability is absolutely important. So let us say I just open up, then I just want to talk to my friend. I just go and click and here is the WhatsApp or WeChat. I start communicating. If it's not available, the reliability is less. The people may not use your service. So henceforth we need this dynamic provisioning capability. Okay, to provide reliable services. And so like this, in various countries, like this WhatsApp is popular. I can use to communicate, or in so I can communicate. So like this, we need reliable services, and these are cloud powered services. So here is the mosaic workflow left side. Then when you image process all those 110 images, you create an image mosaic, and this is the mosaic that is created out of that combination. Because telescope is capturing so many individual images, you put them together to create a mosaic. Correct? This is like a sky, you know yeah. So this is the people from astronomy committee understand, but what I want to highlight is multi-cloud computing is here, and it is applicable in business world, healthcare world, and scientific world. So now with that discussion, so let us conclude, and then after that I will give you pointers to few extra resources that you can refer to study this concept more. To summarize, cloud computing became really successful, already offering you know uh, this compute as a utility services to users on a pay-as-you-go basis. As we discussed earlier, there are numerous cloud service providers are there. They're offering cloud services, and many applications already created. There's a big success of cloud computing. However, this emergence of numerous cloud providers is providing further opportunity to scale your application. And also, if you want to scale your application, you need to make sure that vendor lock-in problem is not there. Okay, that is very important. And multi-cloud computing is also used for enhancing reliability. So this is what we discussed so far. This is very important. So when we move towards multi-cloud environment, so if you build an application for a given cloud provider, it is not possible for you to move it to other. So therefore, we need to have some kind of application platforms that are independent of vendor infrastructure. Okay, so Aneka is one such technology. So this is a software technology, and we have designed and created and demonstrated and deployed for many commercial application, showcasing the power of multi-cloud computing. Once you build your application using Aneka's programming models, and you can deploy on different clouds in a seamless manner without changing your application. No change. So this way you don't have to log on to a specific vendor. And the APIs that we use are also sort of standard. As a result, you are able to execute very easily. So by doing this, you can minimize the cost of software engineering. You can minimize the time it takes to engineer the software. Not only minimize time and cost of software engineering, but also once you engineer the software, you want to deploy those as a service to consumers, you can minimize the cost of computation. So there are numerous applications that have benefited from this Aneka, and today we just saw two examples. One from bioinformatics, that blast application execution. The second from COVID, from satellite. So there are many like that. Gaming, due to time limit, I didn't discuss much, but gaming application is also another popular, which is enabled by Aneka. So those is about Aneka. So after that, we discussed about, of course, before that, as part of Aneka, we saw experiments of running on Amazon Cloud, Azure Cloud, and showcasing the power. Then we moved on to, Cloudbus workflow engine, so which allows you to compose workflow application rapidly. Then you can deploy those applications on multiple clouds based on deadline limit, budget limit, for reliability purpose, for performance purpose. As I said, this workflow engine has been used for numerous applications, including fMRI, functional magnetic resonance imaging, medical application, for special application, that dengue fever outbreak, the propagation. Similarly, maybe you can use it for COVID-19 propagation. And then we finally looked at the deployment of astronomy, images that are captured through different telescopes to create a mosaic using software called Montage on our Melbourne University cloud, and also public cloud. There's creating a hybrid cloud environment, and then conducted reliability experiments. To learn more about cloud computing, so here are the books. So here is a book, Mastering Cloud Computing, American edition, bit expensive, $100. The same book is available for Indian market for around $8 to $10. The same book is also available for Chinese market in our own China language. So for around $3 to $4, so very affordable to users in China. Then for big data computing, so I also edited a book on big data computing. So this is published by Elsevier. So you can refer to it to learn more about what is big data computing, what is the concept, and so on. And so there are many interesting research papers available. So one of them is this, the first paper talks about anatomy of big data computing. When we say big data computing, there are many components, there are many elements, there are various issues and challenges, there are various solutions available. So we have done a very detailed investigation on this big data computing, and also we looked into how cloud computing can help big data. So essentially, big data computing means big data processing on cloud, and a paper on this is published in Software Practice Experience Journal. So you can really, go through this paper to study in depth and understand the concept. So next, we discussed about Aneka. So Aneka has deadline-based resource provisioning policies, and we have demonstrated that the deployment of application for Sun domain on hybrid cloud. And here is our second paper that talks about that algorithm in depth. You can refer to it, published in Future Nation Computing Systems. And after that, we looked at how to enhance reliability of execution of workflow applications by harnessing the power of different type of cloud environment, including spot instance and so on, and minimizing the cost of computation. So that paper on autonomous and reliable system. More recently, we also looked into smart city application. So provisioning, especially data intensive application execution on cloud, along with the deadline constraint. So that paper is published FGCS. And just this week itself, we have presented a paper on this COVID-19 open research data set analytics on private enterprise cloud set up here locally. So here the focus on mining, but mining for identifying insights, but identifying insights in a timely manner, high performance mining. So this paper recently presented at international conference on utility and cloud computing held in United Kingdom this week. So you can see, so just December 2020. So it's a timely innovation and application demonstrating data intensive big data and cloud computing and multi-cloud application engineering, their deployment on cloud environment. So this is the overall summary research paper. But if you visit our website, cloud computing laboratory website at Melbourne University, you will be able to access these papers, and also you can access, for example, software systems. So this Aneka software you can access from Microsoft website, microsoft.com. From here you can download this Aneka and explore. That is the evaluation copy. Then of course the workflow engine, we made it available freely for people to access. So these are our software systems and application studies that we carried out at Melbourne University, and very pleased to share with all of you. So thank you very much for hearing patiently. Here are two contact details from my email IDs. If you want to interact with me from the perspective of research innovation, you can use my University of Melbourne email ID. Or if you want to do something with Aneka, you can access, you can contact me through my Melbourne University email ID, which is raj@manjarasab.com. Or you can access our website to learn more about it. Say for example, if I click, so it takes you to Microsoft. So this Microsoft website. So learn about more about Aneka, to how to build application, and once you build, how to accelerate application execution. And of course, as part of acceleration, you also manage these clouds, manage application, manage users. So all three solutions in Aneka. So when you click on download, so you can see the latest version, Aneka 5.0. Free evaluation copy is available. So numerous users are benefiting from this technology. Yeah. So with this, let me stop here. And of course, you can also visit our cloud computing laboratory. So Cloudbus. So our clouds lab. So clouds.cis.unimobile.edu.au. So you can access that one and then learn more about it. Okay. So these are different sites that you can look at to access our website. Okay. So thank you very much for hearing patiently. So